And Mr. James Burk, would you please come up? Let me tell you about James. James Burk has been an information technology director for the Mars Society since 2011. And this year he was appointed vice president of the Moon Society. A former Microsoft software engineer and project manager, he is currently working as a senior technology manager for a small company in Seattle. He's been a volunteer and an officer for multiple space advocacy organizations since 1998. Let's have a hand for James Burk.
All right, well, thanks everybody, and thanks to NSS for inviting me to come talk here. I'm really excited to talk with you guys about MarsVR. This is a new project that we're working on at the Mars Society. We really are interested and serious about using virtual reality for a lot of different purposes. So first, let me paint a picture for you, okay? Imagine the first crew has landed on Mars. And, you know, we're the Mars Society, so we're still fans of Mars Direct. It's still our favorite plan. And they've got the base set up. They've sent out some rovers and drones to explore the area, and all those high-resolution photos are being beamed back to Earth. And back on Earth, they're assembling all that into a virtual reality environment so that everybody back on Earth, you know, hundreds, thousands, maybe even millions of people, can experience the same thing that the astronauts do. And if we were able to do that, we could explore the area along with them. We could find things that before they do, and even make suggestions of where they could go at the landing site. So we call this idea crowd exploring, just like crowdsourcing or crowdfunding, crowd exploring. So we've been working on the Mars Desert Research Station for about 17 years now. It's our 17th field season. It's just about to finish here in a couple weeks. And we've rotated through there 195 crews, comprised of over 1,200 crew members. And generally these are 2-week rotations. There's 6 to 8 crew members on each rotation. They're generally university students. People that are coming out there to do their own experimentation with geology and biology, astronomy. MDRS overall, the goal is to explore the human factors challenges of landing on Mars and all the things there. But one of the things that we have to do at the Mars Society is we have to train these people every 2 weeks. Every 2 weeks there's a new group, so we have to train them where everything is, what the procedures are, you know, how do you go out the airlock, how do you do EVAs. So as you can imagine, for us, it's getting a little old. So a bunch of us thought, why don't we try to do this in virtual reality? So why don't we make a training environment of the MDRS in VR? And the way we're thinking of doing that is to use a technique called photogrammetry, which I'll talk about in a little bit more. But essentially, we're going to scan the MDRS, all the facilities and the terrain around the MDRS, put that into a VR environment, and use that for training the crew. So they can actually do the training at home before they even come out to the station. Now, the environment will work on the high-end headsets that are out there. The HTC Vive and the Oculus Rift are the 2 main headsets today. But it'll also work with just a computer. So if they have a computer with a decent graphics card, that'll be fine. And most people have access to that these days. So what we're going to do, we're doing a Kickstarter. And we're only 6 days remaining on the Kickstarter. And so here's where we're at as of right now. We're at 84% of our goal. We've raised $23,000 out of our goal of $27,500. And we're very confident we're going to hit this number. So we're very excited about this program. We've been talking about it on the web and on social media for the last few weeks. So you can get to it. There's the first link there is to the Kickstarter. The program website is MarsVR.io. And then now, I actually just discovered this yesterday, you can just Google MarsVR and we come up with the first link. So I guess we're famous. So we're really excited about this program. And we're looking for partners, we're looking for the support of the community, and I want to talk a little bit more about our plans here. So when we build the MDRS environment, we're going to open source it. So this isn't going to be something where it's just a research project and we build it and we use it and nobody else can really make use of it. this is going to be an ecosystem that we're setting up. So we're going to create a core virtual reality environment. It's going to be engineering grade, and we're going to use it beyond just the MDRS. We're going to build it in a technology called Unity, which is the most popular game development platform. And we're going to open source that project that we've made in Unity with the GPL v2 license. And so anybody can download Unity and download our project and do the same things we do with it. We're also going to create several 3D models of the base and the terrain around the MDRS, and we're going to share those as well via Creative Commons Attribution Share Alike license. And then finally, the mission content, the stuff that we're going to do to train the crew members. Initially, we are going to have that be just for us to use, but we are going to offer it to the general public with a Steam key for $30. So if you go on to Steam, which is a really popular game platform to purchase games, you'll be able to get the mission content and experience the same training that the MDRS crew members experience. It's also one of the levels of the Kickstarter we have right now. Now, eventually, we're going to open source that too. It probably won't be for a year or two, but eventually we want to put that out there as well. But by then, we'll be working on additional stuff, so that won't be a fundraising mechanism for us anymore at that time. We'll have other stuff. Again, here's the technologies we'll be using. So Unity and C# are going to be our development platform. We're going to use the new technique of photogrammetry. So what photogrammetry is, it's a way to scan a real life environment and put it into a virtual reality simulation, and it's extremely clear and crisp and high fidelity, high resolution. You almost can't tell the difference. So I'm going to show you a couple videos at the end that shows you some of that. We're working with a gentleman named Oz Balabanian, and he is an expert. He's like a world-class expert on doing this, and so we're really excited to be working with him. We're also going to be using 3D modeling tools. We are going to open source our 3D models, and we're going to make it so that hopefully people can use a free tool called Blender, so they won't have to go buy a high-end 3D modeling package to make use of our stuff. We're going to actually make it useful. We probably will use that ourselves to make some of these. We're going to save it out, export it as a Blender file if we can, so that the community can also use those 3D models on whatever they want to do with them. I mentioned the 2 headsets. That's what we're targeting for phase 1. There are several other types of VR gear out there. As a matter of fact, this one here, the Oculus Go, this just came out on May 1st. This is a $200 headset. So this is kind of what I've been waiting for a while to see, a commercial device that's about $200 that anybody can get, and it's really a high resolution and really good device. So we're going to do some work with this as well. Maybe not for phase 1, but it's on our list. To distribute the software, we're going to use GitHub, which is like the open source website that a lot of projects use to distribute the software. And we're going to have a lot of wikis and YouTube videos and other training materials so that people can learn what we're doing quickly. So we see this as 3 things. There's 3 pillars of what we're doing with MarsVR. First, it's a serious research tool. It's all about, MDRS is all about the human factors challenges for the first human landings on Mars, and MarsVR supports that work that's already happening. Also, we'll be able to pilot the idea of crowd exploring. So we'll be able to prove out at the MDRS how we would do this for real on Mars. And then finally, it's going to be an engineering grade VR environment that ultimately, in the later phases of this project, we're going to use to make Mars terrain with real data. And I'll talk a little bit about that. Second pillar, this is going to be a STEM education platform. So we want to build this so that teachers and students can use it in class. The teachers can use it to talk about Mars, talk about geology, but students can use it to learn 3D game programming and C# programming and VR development. So we're going to have training for Unity, but we're also going to training on how to actually use our environment, how to open it up and customize our environment. Third pillar, it's a public outreach tool. So I had the opportunity, thanks to JPL last September, to go out and see what they do with Microsoft HoloLenses in the Ops Lab there. And it was a very visceral and realistic experience that I experienced there. They basically have the Curiosity rover data coming in every day, and you can put on the Microsoft HoloLens, and you're standing right next to the rover, and you can see where it was yesterday and where it's going tomorrow. And so, you know, the scientists at JPL, they used to print out maps and look at them with magnifying glasses and think about where they're going to drill next. Now they just put on the VR headsets and walk around. They're like, oh yeah, we should drill there. So it's a really advanced setup they have at JPL. I talked at length to some of them while I was there. And when I got back to Seattle, the first thing I did was I called up the Museum of Flight. And I said, hey, I want to work with you guys on VR. And I want to have something like I experienced at JPL available to the general public. And how can we do that? And so we're actually working really closely now on setting up some of the work we're doing at the Mars Society, but also having that be available in museums like the Museum of Flight in Seattle. Others have done Mars environments, like the JPL I just talked about. HTC Vive has a Mars environment out of the box, and there's been various Mars games like Mars 2030. But there's always been barriers to having them be broadly used and distributed, and we really hope that with MarsVR, like eventually lots of people are going to be taking advantage of our software. So here's the team we've assembled so far. This is not everybody, but we are going, and we're adding to this constantly. But these are some of the great folks that we're working with so far. Shannon Norell, you may have seen his name with the HP Mars Home Planet efforts. He was one of the founders of that. He's no longer with HP, and I should mention HP is not an official sponsor of our project here, but we're working very closely with Shannon. He's been in all of the meetings we've had on this so far. He's a world-class VR expert. He runs the Bay Area VR meetup and just has a lot of experience, worked at Apple, Microsoft, HP, a lot of places. So he's working very closely with us. I mentioned Oz Balabanian, the photogrammetry expert. He's got amazing stuff online you can check out. Dr. Greg Shamatov. So we actually have an astronaut on our team. Greg Shamatov is a professor of engineering at Texas A&M. And he and his team for the last 2 years have been working on spacecraft VR, which is just starting to see the light of day. It's really amazing stuff they're doing. And we're working closely with Greg on how we can leverage some of the things they've learned. For example, they've done a lot of work on atmospheric models and on other space physics that we may be able to leverage with the work we do. We're working directly with a senior engineer at Unity, Jeff Dillon, who actually happens to be a Mars Society member, which was great. And then Robert Madsen. Robert's also another Mars Society member, has presented on VR at our conference. And he lives an hour away in Grand Junction, Colorado from the MDRS. And he has experience with photogrammetry too. So we're really excited to be working with Robert and his team at Synaptics Games. And then finally, Stuart Spence is a guy I've come across. He's an educator and a Unity expert. He has a YouTube channel with thousands of subscribers on all his Unity tutorials, but he also teaches 3D programming to high school students using Unity. And he created an open source game called Martian Agora. It's something that most people haven't heard of. It's open source, and we're learning a lot from that already. So he's on our team as well. Here's the Kickstarter levels. I'll go through these really quickly. So, you know, anybody can help out with us. Even students can help contribute to the Kickstarter at the $5 or $10 level. You know, most students should be able to afford that. At $5, you'll get a digital certificate and a personalized thank you from Dr. Zubrin and the team. $10, you'll get the digital poster of our final MDRS render. And then we have these embroidered patches. So there's the 2 Crowd Explorer patches, the male and female one, and then the mission seal on the top left. Those are all embroidered patches we're going to offer at the $25 level. Steam key, I mentioned that to unlock the mission content. So everyone will be able to download the environment for free when it's available in October. But folks will be able to get the Steam key to unlock the mission content earlier as well. And then also we have the early access level. So if you get early access, you'll probably get access to the environment no later than September. Also, we have another physical reward, which is this metal medallion. So this is a really popular thing in the VR community. A lot of projects make these and raise money with them. So we did a limited run of 250 of these. It's got the Mars Society logo on the front. It's got MarsVR on the back. It's real shiny. It's nice and heavy. It's really cool, and it glows in the dark.
Yeah.
And then finally, The Mars Society typically picks crews for the MDRS. They have to apply and send in a big application, and we usually get more applicants than we can choose for every different field season. So for the first time, we're actually offering seats at the MDRS as part of this Kickstarter. And it's the very next crew in the first crew of the next field season, which is in October. It's going to be like mid-October, crew 197. So you can actually jump the line and become an MDRS crew member if you participate in our Kickstarter. So let's talk about phase 2. So we've got all this planned out. We're going to go execute it this summer. We're going to build this environment. What's next? Because we're in this for the long haul. So phase 2, we have an idea that we would basically have, you put on the headset, there's the globe of Mars in front of you, it's rotating around. I have a render from Nat Geo on here, but the reason I picked this one is it has all the feature names on it. So all the feature names are tagged on the globe, the landing sites are tagged, you can maybe spin the globe around, with your controller, and you click on it, you point at something on there, and it zooms all the way down to the surface, and you can walk around there. Wow. So it's going to take us some work to pull this off, but from a technical perspective, it's possible. There's people that have already done proof of concepts of this using the MOLA altimeter data. The MOLA altimeter data is from the Mars Global Surveyor mission, and it has full planetary coverage. And then we would overlay various orbiter imagery from the MOC on the MGS and from HiRISE and CRISM on the MRO mission, and the Indian. We'll look at whatever's out there basically to do this. Obviously certain places will have higher resolution than others. We may roll out certain sites first and then do the rest of the globe. But this is something we want to work on next with phase 2. So I want to show you guys a quick video. This is our Kickstarter video. Hopefully the sound will work. Let's see.
The MarsVR project is our new effort to understand how best we can make use of virtual reality technology with the ongoing exploration and settlement of Mars.
Virtual reality could play a critical role in the human exploration of Mars. It will allow millions of people on Earth to travel along with the astronauts and directly participate and assist them in the exploration.
Having virtual reality as an actual engineering tool is of great interest to the space industry as it sits now and for the future of space exploration.
The idea is we send a robot platoon to Mars, map an area and allow people to explore it in virtual reality. Later on we send people to map much larger areas and have people travel alongside the astronauts as virtual reality assistants and scouts. Well, what could we do now? Well, at the Mars Desert Research Station, we could try a demonstration of this method of exploration.
MDRS is important to the Mars Society because it gives our crew participants the opportunity to explore their role in getting humans to Mars.
Since 2001, the MDRS has been host to over 190 unique crews, comprised of over 1,200 crew members, and all of them get trained on where the facilities are and how to do certain procedures.
I'm hoping we can use virtual reality to give crews an experience of what their mission will be like before they get to the station.
Phase 1 of the MarsVR program will focus on designing training simulations for use at the Mars Desert Research Station, and will be able to provide direct assistance in the training of the crew members. We'll create a virtual reality environment based on the facilities of the MDRS and the real physical terrain around the area. Every moment at the MDRS is precious, just like being in space, and we want them to make the most of it all. If we raise enough funds with the Kickstarter, we'll create additional mission scenarios and places to go on EVA at the MDRS.
Hopefully we can apply these techniques to actual missions that are used on the Red Planet And we're looking for your support to back the project so we can build this amazing, functional VR tool for our futures.
We're asking for your help with this effort. Help us pioneer the exploration of Mars using virtual reality.
All right, and then I'm going to play a little bit of this next video. So this one, I've been doing weekly program updates, and I've been putting these up on YouTube. So this was the one from Monday this week.
Here's an update on the MarsVR program. It's been another great week, and we're really close to our goal of $27,500 for the Kickstarter. And we're expecting a large donation to come in, so we're really close, but we could still use your help. We don't want to just reach our goal, we want to exceed it so we can capture more terrain at the MDRS. So please consider upping your pledge. If you add $20, then we'll send you an embossed patch. And if you add $50, we'll send you a metal medallion. Every little bit helps as we're so close to our goal. This week we're announcing several new partners for the MarsVR program, and I'd like to take you guys through them. Shannon Norell, formerly of HP, Apple, and Microsoft, is one of our key participants on the MarsVR program. I've been working with Shannon since some of the very first meetings that we've had on this project. Oz Balabanian is a filmmaker, virtual reality expert, and an expert on photogrammetry, which is the technique of taking a real-world environment and turning it into VR so that it's photorealistic. We're really hoping to leverage Oz's skill set with the work we're going to do at the MDRS. He's going to be able to help us translate the real-world terrain and the facilities into something that looks amazing in VR. Dr. Greg Shamatov is a former astronaut, professor of practice at the Department of Aerospace Engineering at Texas A&M University. He's also the head of the Aerospace Technology Research and Operations Center at the university. He's a founding member of the Mars Society. He's been working with a team of students for 2 years on spacecraft VR. We really are impressed by what we've seen so far from spacecraft VR. We're working with Dr. Shamatov to try to find ways that we can leverage the great work that he and his team have done on spacecraft VR as we begin to work on the MarsVR Phase 1 environment. Jeff Dillon is a senior engineer at Unity Technologies, and he's also a member of the Mars Society. Unity is the leading framework for creating 3D environments for virtual reality. It's got the biggest developer ecosystem, it's got a lot of momentum behind it, and it can create cutting-edge virtual reality experiences. We're hoping to leverage Jeff and his team to help build the MarsVR environment and create a vibrant developer ecosystem. Robert Madsen is the CEO and founder of Synaptics Games, and a Mars Society member who has presented on VR at our annual conventions. Robert and his team have experience with VR games and photogrammetry. And what's great is they're only about an hour away from the MDRS in Grand Junction, Colorado. Robert has come out and spoken at the Mars Society convention about VR. He's volunteered at the MDRS and some of our work parties. And we really are looking forward to partnering with him and his team to do great photogrammetry work. The fact that they're only an hour away in Grand Junction, Colorado, will be really useful in case we need to do any reshoots or rescans of the area after the first round. So we're really looking forward to having Robert and his team help us be key contributors to what we're doing. Stuart Spence, which I talked about last week, is also involved with the project. We're looking at him as a advisor. The fact that he's an educator and has taught 3D programming in high school, we really want to leverage his experience as an educator so that we can create a good platform for STEM education and so that folks like him can use it to teach computer science in schools. And we also have another developer named Alexander working with us. Alexander's worked a lot with Shannon in the past. He's a really talented VR developer, and we're really looking forward to having him join the project and what he's going to be able to do for us. So we've also started thinking about phase 2 and what we want to do after the MDRS environment is complete. Imagine this scenario. You place your VR headset on your head and in front of you is the globe of Mars. And it's rotating around, it's got all the named features on it tagged, all the landing sites are tagged on it, and you can rotate it around, you can click on something, and as soon as you click, it zooms all the way down to the surface, and you can walk around in that place. That's a long-term vision, but it's something we think could be real. We can see from a technical perspective how to achieve that with virtual reality and the existing NASA data. And so we just want to go do the work in phase 2 and beyond to make that a reality. We've looked at some of the work that others have done to take MOLA altimeter data from the Mars Global Surveyor and create 3D terrain models of Mars and overlay on that orbital imagery from the Mars orbital camera on the Mars Global Surveyor, the HiRISE camera on the Mars Reconnaissance Orbiter, and the CRISM experiment on the Mars Reconnaissance Orbiter, as well as all the other sources available, such as the Indian Mars Orbiter mission and the Mars Express that was done by ESA. And this is really an area that we'd like to go deep on. We'd like to explore what else is possible with creating a 3D environment in virtual reality that uses all the real data coming back from Mars so that we can have a really high fidelity experience. That's all for this week. Until next time, I'll see you on Mars.
Just introducing the rest of the team, basically. So yeah, so that's what we're working on. The last thing I wanted to leave you with was I have another project actually. I only got one slot at this conference. I wanted to, but one of the things I would have talked about at the other slot is how all the space groups can work together. So I'm with the Mars Society. I'm also with the Moon Society. We're a lot smaller than the Mars Society, and we're actually in the program as a NSS affiliate. The Moon Society is. The Moon Society started this wiki about 10 years ago, as well as a Lunarpedia wiki and some other space-related ones, some science fiction-related ones. They started these set of wikis, but they didn't really have enough manpower and volunteers to run them all. So with my Mars Society hat on, I approached them last year and said, hey, why don't we work together on MarsPedia? Why don't we set up a governing council? We could pull in Bruce McKenzie and the Mars Foundation, and some folks at Mars Society. The education director, Nicole Willett, has contributed a bunch of encyclopedia articles she wrote. So we're doing this now, and we're building this out. We just went through, we categorized all the articles in there, and the reason that's important is because Mars Society has a papers archive of all the conference papers that anyone's ever submitted to our conferences over the last 20 years. And we have all that up on a website called marspapers.org, and we're categorizing those the same as MarsPedia so we can build a search engine for all that content. The other thing I'll mention, I talked about the areography section, that's geography for Mars. We're actually going to tie this in with the phase 2 MarsVR stuff so that you will have an encyclopedia article for each named feature on Mars. That doesn't exist anywhere today, so we're going to work on that too. But those are some ways, this is an example of ways that the space groups can work together. And that's something I'm personally excited about doing. There's projects like VR, like an online encyclopedia that people can participate in. I would ask the space groups like NSS and Mars Society and Planetary Society and all the other ones out there to try to find shared goals that we can all help each other out with. There used to be a site called the Space Chapter Hub. Peter Koch was here at the conference, worked on that back in the day, and we actually have that content at the Moon Society. We're putting that site back together to help all the space chapters. So that's another way we can help each other out. I'm a member of the NSS Seattle chapter. I've been there, a member there for 20 years, and I go to their meetings, and I'm also the Mars Society chapter head in Seattle. So I try to have those two groups work together as much as I can, because we have a common goal of trying to get the word out about space. We should be promoting each other's meetups, and the Facebook share button is a great thing. So that's all I had. Thank you very much.
We're past it's it's 5 o'clock, but if he's willing to stay, and you're willing to stay, you can take some questions.
Yep.
And I have a comment. And I applaud the fact that you're trying to integrate these groups and have them mutually supporting each other. Because I think that's desperately what we need.
Yes.
Anyway, question? You have
Questions, anyone?
Will your stuff run on a Mac?
That's a great question. A high-end Mac, sure. Most Macs are high-end, right?
I hope the one I have is.
I think you'd need the discrete graphics. So you need like the NVIDIA graphics processor that the Mac would.
1050 Ti equivalent is better.
Yeah, yeah. So as long as if you had that, it should be fine. Yeah. Not like a Mac Plus or like a Apple II GS. Those aren't going to run the VR environment.
Anybody else?
Are you going to be here tomorrow?
Yes.
Do you have something I can put on an Oculus Rift?
I don't have any running code yet for this. We have that demo I showed that's on GitHub. You could try that out. That's the prototype environment that some other folks did for the MDRS.
I'm going to have an Oculus Rift. I'm going to set up downstairs tomorrow afternoon.
Mm-hmm. Table 11, I think.
But I do have other applications that have Mars and lots of those flags.
Do you have the Buzz Aldrin one for Oculus? Yeah, that's the best one, I think. So.
I do have a question about, also about your simulations.
Mm-hmm.
I couldn't understand, or I wasn't it wasn't clear to me how much actual physical movement is going to be allowed, as you're
Yes.
experiencing. When you were talking about, you start with a globe and then you drill down.
Yes.
How much actual movement will there be walking around and so forth?
So that's a great question. One of the issues today with VR, when you put a headset on and you basically have like a 10 by 10 area,
Yeah.
the HTC Vive has these two like sensors that are on tripods. You have to
Right.
kind of stay in the box.
Yeah.
You can walk around and you can kind of turn around and the whole environment turns with you, but people get motion sick a lot. And especially if you start having movement inside the VR environment, like for example, there is a game called Mars 2030 where you're driving a rover and you're like bumping up and down. And I got sick in about 2 minutes of that. So the way to do that, the right way, so to answer your question, yes, you are going to be able to move around the MDRS. We're actually going to do a square mile of terrain around the MDRS, so there's going to be a lot of terrain to explore.
Wow.
But you're not going to actually walk. What you're going to do is you're going to take your VR controller and you point it, and you point it at a place, and you click the trigger, and you teleport over there.
Got it.
So that's kind of that's the best way to do it, so people don't get motion sick.
Okay.
Yeah.
Okay.
But if you had a 100 by 100 like VR environment at your house, you could walk around in it, sure.
Yeah, Robo Recall does that real well.
Yeah.
Play Robo Recall.
Mhm.
Okay.
Yes.
All right.
Any
Anybody
other
else?
questions?
Let's have a nice
Thank you guys.